If you find these videos helpful, please consider supporting AddOhms and the Bald Engineer on Patreon.
Hello, and welcome to a live stream.
My name is James and I'm the Bald Engineer. As you can tell, this is not my usual setup. I've actually physically moved in the last couple of weeks and I'm still waiting for most of my stuff to show up. So all I've got right now is my scopes and my cameras. Let me know in chat if you can hear me okay, and our usual way is tell me your favorite component, or I guess you could just name a component, but let me see some component names in the chat. Oh, I just realized I forgot something. Be right back. Well, you'll still be able to hear me, but I'm gonna walk away from the camera for a minute. Are you kidding me? Hold on. Hey guys, I'm really sorry. I had a delivery scheduled for 4 hours from now and they're here right now. So I'm gonna get started in like 5 to 10 minutes. Really apologize, but I gotta take care of that, so sorry. Really wish I had the trivia. All right, anyway, I'll be back in just 1 minute. All right. Okay. Oh, boy. Really apologize for that. Yeah, I had a delivery scheduled for this afternoon, and I thought we were going to run into them during the stream. I didn't expect them to call as soon as I hit start, so that sucks. Okay, hello to everybody in chat. Let's try this again. What's one of your favorite components? Be right back. Okay. Holy cow. I think we're finally going to be ready to get started. That time, the delivery person wanted to know the best way to get out of the neighborhood. Even though I told them I was live streaming and we needed to do this quickly, they felt the need to come back. Okay then. Hey, Thomas, good to see you. Stallion, I think might be the first time I've seen you here. Anton, hope you're still around. Imp Pirate, good to see you. Okay. Thomas was asking what happened to the op-amp circuit measuring current. It is not finished. It's sitting in a box. I had to put it on hold because I moved, and so waiting for all of my other stuff to show up so we can continue that circuit. You gotta be kidding me. That was an automated call to tell me that my stuff has been delivered. Holy cow. Holy cow. Okay. So, op-amp circuit. Hold on. I might switch from tea to beer a little bit early today. Just might have to. Hey Rod, good to see you again. So backing up, what happened to the op-amp circuit? It's on hold for the moment because, as you can tell, this is not my usual setup. I moved a couple of weeks ago, and now my stuff is on its way. In fact, it's supposed to be delivered tomorrow. So Wednesday's stream will hopefully look and really hopefully sound different. So I'll get back to the op-amp circuit probably starting next weekend. That's why we're doing some KiCad, been doing some KiCad stuff the last couple of weeks because it's easy to do with my laptop. Yeah, this is by far the most stressful live stream I've ever done. Anyway, we're gonna do some fun stuff. We're gonna design some circuits in KiCad. So on Friday's stream, we took a couple of sensors. Oh, here it is. We took a couple of sensors from this Grove board and we created a little bit of a data logger. And so now what I want to do is move from that sort of prototype platform to something more permanent. And what I realized is there's a couple of products out there that have a microcontroller and a bunch of sensors and then either a radio or a SD card reader or SD card socket. And the thing is, they all have like sensors that I don't need, and they're all in the like $30 to $40 price range. And what I wanted was some things to measure temperature and sensor that I can sprinkle around my house so that I can sort of understand the thermodynamics of where I'm living. And so I looked it up, and that's only gonna be like $6 or $7 worth of parts, even in low quantity. So I decided, why don't we design a custom sensor board, and then we'll do some kind of logging with it. So that's what we're going to work on in this video, is designing that board, and I'll walk you through the path that I decided to go through here in just a second. So, okay. Now, let me get my computer ready. Oh, that's why this is the one I want. Let's come over to here. Okay, so how do I want to do this? So here's what I was thinking about. the very first thing I found was, the very first thing I did was I went to Adafruit and I looked at their feathers, because Adafruit tends to have pretty good combination of sensors and boards and stuff. And so I just kind of looked through these and try to find something that I like. And in fact, this NRF based feather is what I liked the most. And so it had a bunch of sensors. It has a Bluetooth low energy radio, which I'm not sold completely on. And then the reason I'm looking at Adafruit feathers is for two reasons. One, I just like the compact form factor. It's relatively small, and there's lots of shields and things that go into it. So there's a nice ecosystem around it. But they all also have a charging circuit for a lithium-ion battery. Because if I go look at like the Arduino BLE33 Sense, or Nano 33 IoT and Nano 33 Sense, no battery charger. If we look at the Teensy 3.x or the new 4.0 and 4.1 boards, there's no communication option. And so to me, the feathers tend to have the right combination. Now, what I don't like about this Sense is it's $30 and it has sensors I don't care about, like a gyroscope, accelerometer, and magnetometer. And so I don't really need or want that. And then also this is like $30 and it's gonna be like $35 after I have it shipped. They're not in stock anywhere. And I got to thinking about it, I have a ton of feather boards already. So I already have, like when I started looking through this list of feathers, I have stuff like the ESP32 version, as well as, let's see, there's a Bluetooth version on here that I have, the M0 Bluefruit LE. I have like 4 or 5 of these from a previous project. So I already have the feather with a microcontroller, with a radio, if I want to use a radio, as well as a charger. So then I thought, well, maybe they just have a wing. So instead of a shield, they call it wings. And then when I looked at the wings, I'm just gonna scroll down, there wasn't really anything that was just a bunch of sensors. And again, what I started to realize is a lot of these all-in-one sensor things have accelerometers on them. And I don't want or care about that. To me, it's just extra expense. Or they have a BME 280, which is humidity and pressure, as well as like temperature and pressure, as well as a temperature and humidity sensor. So there's kind of extra cost there. So, okay, so we talked about that. I'll be right back. I didn't sign the paperwork. Okay. So, so what I was saying is, so I've got some of these feathers, like this M0 feather. Oh, I like this one because it has the SD card reader. So I have one of those. Then I found the FeatherWing with an RTC, and I remembered, when we played around with the Grove board, I realized there's no RTC, so we were using timestamps from millis, which isn't going to work too well when the processor goes to sleep and wakes back up. So we need to add an RTC, and we're going to add my favorite, which is the DS3231. So we'll do that. And then the rest of these I was just looking at. Oh, and I just wanted to point this one out because I didn't know that they have this, but they have a feather shield or a feather wing where you can actually attach a Teensy 3.x to it. I don't have a need for that right now, but I thought that was pretty cool. Yeah, turn on the do not disturb. Yeah, I told them I was in the middle of a broadcast and they keep coming back. I don't understand. Hey, Johnny from Sweden needs a fancier doorbell. I have one. I haven't installed it yet. Hey Yasser, good to see you as well. Man, I don't know that I've ever seen you in Twitch before, or maybe I have and I just didn't recognize your name. Okay, so that's where we're at. I want to build something that fits onto a shield, and I want it to have the following things. I want a temperature sensor, humidity, light, sound, a micro SD card, and an RTC. And so I actually, for these 4 sensors, I'm just going to copy some stuff that Adafruit is already using, because then I know there's already software available for it, and so we don't have to go and develop a whole bunch of stuff. What I do need to add to our list of components, though, is the SD card reader and an RTC. So we'll do that here in just a second. So the final reason why I decided to just make a wing for the feathers is that I'm not positive yet on how I want to do wireless, or if I even want wireless in this system. So instead, what I was thinking is, now this only applies to me. If you don't have feathers, then this won't apply to you, but I already have a bunch of feathers. So I'm going to put all of I'm going to put only the sensors I care about on a wing, and then that way I can combine that with other wings or feathers to get whatever wireless functionality I want. So I think that's going to be a pretty good approach, and it's also going to be relatively inexpensive. Now, again, it's inexpensive for me because I already have some of the boards. So if you use Wi-Fi, you wouldn't need the RTC. True, except if I'm using Wi-Fi, I'm going to want to wake up and go back to sleep as soon as possible, and I don't know that I want to wait for I don't want to wait for a NTP time sync to happen. Can't every device send data to the Raspberry Pi, so you don't need an SD card? I mean, that's a good point. The reason I want the SD cards is for in case I'm in an area or I place it somewhere that won't have wireless access. So I'm just planning ahead that somewhere I place one of these won't have wireless available. So that's why I figure a micro SD card slot, that'll be the backup that it'll save. If we do get wireless functionality, then I'm just going to do like MQTT to my house Pi. The trig board from Kevin Dara. No, I have not. Is this going to be, we don't need to do the stream because somebody already made exactly what I want? Because that's what I actually thought when I saw that one Adafruit board. However, it wasn't, it's still not quite what I wanted. ESP32, Wi-Fi, yeah. Okay, yeah, that's pretty cool looking. Well, actually, I'll take a look at that for something else I have in mind, but I'm still going to head down this path. Again, the reason being is I already have like an ESP32 feather, so I can already make use of that. Doorbell says, go away, I'm streaming. Yeah, okay. Last is we get to do something new that I only did one time in my life before today, and that was to make the screenshot or the thumbnail, which is we're going to use a template in KiCad. So, okay, coming back to my list of requirements. So, like I said, we've sort of solved the wireless thing because I'm basically going to just make a feather or a wing that can plug into anything that's wireless. So in terms of the sensors, here's what I did. I went and used Octopart to create a BOM or bill of materials. And so I actually already found the light sensor that this is based on some of the other stuff that Adafruit uses. And I'm just picking the sensors that they've already picked or already used in the design, because then we have a reference that we can look at and there's code already written for it. And you know, I think it just makes sense. There's definitely cheaper options available, but the thing that got my attention is at this point in quantities of 10, I'm only buying about $8 worth of parts. Oh, and in fact, this isn't correct because I don't even need this anymore because that was from my old design. Because originally I was going to actually build a microcontroller onto this, so I didn't want to do that. Now, what is going to bump this cost up is I want the DS, 3231. And the thing is I don't know what the package I need is. So let's go grab its data sheet real quick and see what the package codes are. How often do you want to access the data from the boards? No more than once a day, maybe every couple of days. Basically, I wanted to do this in my previous house as well, and I just never got around to it. I just want to get a benchmark for how much temperature variations there are in parts of the house. That's the primary thing I want to do. The light and sound sensors are because I'm thinking ahead, and I might use those as part of my home automation stuff. And so that's why I want those sensors in this board. Yeah. So in those cases, and that's where I got to realizing in those cases, I actually do want to have wireless connectivity. So that's why I like going this Feather route. Okay, so it looks like if we look at this, let's see if you guys, that's probably obscured a little bit for you guys. The DS32, so S, 16 pin small outline. And then, oh, so it's just temperature range difference. So what we're going to do in Octopart is I'm going to add both of these because I want to just see real quick if there is a price difference between them. So we'll do an S and then 31SN. All right, it says multiple matches found. So I don't think it's actually going to matter. So we'll do this and then we'll do this. Yeah. Okay. It looks like it's, yeah, so of course the wider temperature range is a little more expensive. I just wanted to double check. Sometimes if the production quantity is higher, it could actually be a little bit lower. Remember to update, man, update, yeah, KiCad 5.16 did come out. I did actually totally intended to start the stream by upgrading KiCad so we can see what's new, but we're gonna have to change that. Or we're gonna have to do that later on. I've already had enough fun for the day. Anton's asking if there's only one package for this chip. Yep, there is. It's just, as far as I know, there's only the one. I've never seen a smaller one. Why not use the MCP 7940N? The only really valid reason I have is I already have some of the DS3231s and I know how to use them. I bet you this is, let's just see. Although that looks nice and cheap, so I will, I'm going to do this. We're going to look at that one at a later time. One of the reasons I go with the 3231, even though it's very expensive, is because I had so much trouble with the 1307 that I just decided a long time ago I wasn't going to use another one. And so, yeah, I just was like, yeah, we're gonna go this route. If you don't want a Raspberry Pi connector as a data server, you could use that app for your phone. Yeah, except my phone's not always at home. But I actually do have a Raspberry Pi that I leave set up all the time. And it's actually what runs the trivia for the live stream, among other things that I do with it. Which is why I don't have the trivia right now. So I will probably just use that for the data collection. Okay, so that's what our bomb's going to come out to be. Although, gosh, all of the other sensors combined cost as much as the RTC. That seems kind of ridiculous. I mean, in theory, excuse me, in theory that's the case, because if we had to build these from new, but since I already have some of those chips, it's technically free. But gosh, let's go ahead and design this one in, and then we might go look at like the MCP that Yasser recommend it because I'm not using a 1307. That's out. That's not happening. Okay, so these are the main parts we're going to use. We already started on one. Let's grab the data sheets for all of these. So let me, I probably have this one somewhere, but let's go ahead and just get it going. So we'll go into projects, BaldSense, and then do data sheets for SenseWing, because we'll probably need or want these at some point. So I'd rather, let's save them now. Yeah, let's see, MCP, I'm looking for a PDF. It's from SparkFun. That's probably fair enough. Oh, this is, oh, actually, let me take that back. I don't need this one because again, this was, we're going to use, this was the battery charger, which we're not going to use. So that saves us 59 cents. This is going to be the temp and humidity sensor that I'm going to use. So let's see if we can't get a data. Actually, I just, what is this? Why is AT&T taking over my Google search? I wonder if the dots made it think that it was, man, I don't like getting my data sheets from a distributor. I like getting them from the manufacturer, but here we go. Why do you need a battery charger? I don't. That was before I realized I was going to use the Feather, so that's why we just deleted it, because we are not going to need it. So which one was I looking for? Oh, why do you guys have to make this so difficult? SHT30 DIS. SHT30 DIS B. I'm pretty sure it's this one. Don't tell me these are all the same and I just wasted time looking. Okay, I hate when they do that. I think they have individual pages for SEO reasons, but it's like, is it really necessary? Let's save that. Log in. Just lost my chat window, so I got to get that going again. See, this is what we get for Friday's stream for going so well, is everything bad got saved up and happened today. Go figure. Pies are great. You can touch screen and all kinds. Yeah, actually you do all kinds of stuff with it. In fact, so what I have set up on mine is I've got a TFT, 3.5 inch TFT with touchscreen. And then at one point I had the touchscreen controlling some of my early home automation stuff. And so I probably won't go back to doing that because I've got a whole nother idea that I'm doing. But I just think, I just like having a Pi just sitting on my network so that if I need to do something, I can easily do it. Let's see. I'm not seeing from ST, so okay. We'll use a distributor's data sheet. Having worked for a component manufacturer, I know that distributors are not great at keeping their data sheets up to date. So that's why I usually try to just get them directly from the manufacturer. And then okay, that's better. But I try to get data sheets directly from the manufacturer because, what do you call it? That's not what I want. That's an app note. They just don't stay up to date. Okay. All right, so we already got that one. I was just thinking because I had the tape and reel code on it that maybe that's why I couldn't find STs. So we'll do that. Hold on. You mentioned sound systems on the board. Can they be used for voice recognition? They probably could be, but I'm not going to, because you have to do too much listening, and that's going to be too much power. But yeah, because it's a PDM microphone, which means it doesn't output an analog signal. It actually puts out basically like a pulse width modulated signal, which at first sounds like it's limited to what you can do with it, until you realize cell phones, laptops, all those kinds of devices use a PDM microphone. Mouser generally redirects to manufacturer data sheets. No, they don't, actually. Mouser is actually one of the worst, because not only do they not redirect to manufacturer's data sheets, but they always add a page to the PDF with links to similar products on their site. So not only do they host the PDFs, but they actually edit almost every single one of them, which is another reason I try to avoid the distributor data sheets, because you don't know what they've done to them. Okay, let me do a quick thing. Test message. Okay, yeah, I lost my chat for a minute. Okay, Broadcom. Broadcom. That can't. Is this really a Broadcom sensor? It is, from Avago. I didn't realize that. Are we even allowed to have a data sheet for it? I guess so. Okay. All right. So that covers those. Yeah, actually, let's try something, Stephen. I'm open to the idea that I could easily be wrong. So let's just use as a one data point example. So we each have a 50% chance of being right. So if I go to Mouser, and let me zoom up a little bit so we can make sure you guys can see it. Look at the data sheet, and the link to the data sheet is mouser.com/datasheet blah blah blah. I click on it, it is still at Mouser. And if we scroll to the bottom, on the bottom, here's the page that they add with links to the products. So totally random example, didn't even think of it on this one, just to point out that is actually what Mouser almost always does, is they ruin the PDF and they host old versions of it, just like all the other distributors. So, okay, 1, 2, 3, 4, got all those. Okay, so we got the data sheets now, so that's gonna be good. Let's get over to the KiCad part. But I at least wanted you to see that we're going to go get the data sheets. We looked at the DS3231, where we know that was the part we wanted to use, but in order to make it orderable, we did need to have a ordering code, which is why we had to have the S. So there we go. Okay, let's go over to KiCad now. And what I'm going to do is, even though I've actually already done this, I want to show how to use a template, because I didn't know how to do it, and I think it's pretty cool. So let's go in here, let me delete that folder. Yeah, no problem, Stephen. I mean, the only reason I was even slightly triggered on it is because I worked for a component manufacturer, and while we appreciated the relationship we had with Mouser, which was a very good one, and I liked the people I work with, they were all super nice people, it was just really frustrating to me that they would do things like add pages to a data sheet, because I think from a marketing product manager's perspective, I understand what's going on, makes sense. It even helps with SEO. It's part of, Google picks up on the links and builds a little bit of credibility. But from an engineer, it just bothers me that a distributor shouldn't be opening or modifying a PDF for a data sheet. It also bothers me that, it doesn't. It slightly bothers me that distributors store data sheets on their server instead of linking you back to the manufacturer's original data sheet. But I'm willing to let that one go for just a little. I can let that one slide, because there's a couple of reasons that are good for doing that, and then there's the bad reason, which is why they actually do it. The bad reason is they're all super scared that you're going to go to a new website and then not come back to theirs and buy something, which for a datasheet makes no sense to me because I think we all open it in a new tab anyway. But the other reason it does make sense is what if the manufacturer's site is down or they move the link or whatever. It is nice to be able to say open up an order page, like an order history page, go to the part and get the datasheet for that part right there. So from that perspective, I do appreciate it, but I wish they would at least add like, you know, get original or go to original or whatever. Like I think TI started putting the URLs in their data sheets, which I really appreciate it, even though I happen to know that some distributors would delete those. So yeah, I saw that was discontinued, but we're going to use it anyway. I want to get moving forward. So what's going on here is, so since we're going to make this into a feather wing, there's a particular profile for that wing. And what we could do is basically draw it all from scratch, or the better way is I did a little bit of searching and I found this project from this person where they've actually created a KiCad template. And so a template will allow us to shortcut and already have the form factor available. And so what I'm going to do is instead of doing new project, I'm going to do new from template. And then we're going to browse to where I downloaded it. And I did this so that I can get it from my other computer as well. So it's Dropbox, KiCad, downloaded libraries, FeatherWing. I think I have to open up this folder, say select. I'm getting this error about incorrect sRGB profile. I'm not even sure why KiCad cares anything about sRGB, but okay. And then I'm going to select Feather and say OK. And so now KiCad is asking where do I want to save the project file. So I'm going to go and put that into my projects folder. And I'm calling this Bald Sense for the moment. And we're going to call this Bald Sense Wing version 1. DigiKey redirects, huh? Okay. Color calibration manager. Yeah, I mean, sRGB deals with color calibration, but I don't understand why KiCad would care about that. That doesn't really make sense to me. So if we look in the schematic, then we can see there's a schematic for the pinouts. And what this person, if you read the GitHub README, what this person has actually said is instead of labeling these like D1, 2, 3, 4, 5, different feathers label their pins different. So he just called them F0 through 6 so that it's a little more consistent. So we'll have to maybe add some text here that kind of maps those back and forth from other pins. So we'll give that a shot. And then if we go and look at the PCB file, you're running 5.1.2. There's so many fixes since 5.1.6. Yes, I understand. Also, this is my laptop, which I don't use KiCad on quite often. So this is out of date. Like I said, I was originally planning to upgrade it, and then all hell broke loose as soon as I hit start stream. When someone makes a sensor, yeah, well. That might be a new animated GIF that we could add to the stream, is just my face and my head, and it vibrates every time I make a mistake, but then people might think I have Parkinson's. So, okay, so this is cool because now we've got the footprint that we need as well as the pinout, so now we can start adding our other components. So let's get into doing that. So one thing I want to do, and I always like to do this just as a, just to help keep my sense straight. Let's go ahead and copy these so that I remember to add all of them. And then that way we can also add notes if we need to as we're going. So we'll get some notes going. Oh, you know what we didn't find yet? We need to find a micro SD card. Oh, micro SD card, and then we'll also need a and we'll also need a coin cell holder. And so what's the really popular one? The 3032. Then there's a smaller one that's like 2028. The one that's a step down from the one that everybody uses, I've got a whole box of those. Well, now you have me wondering, is it Steven or Stefan? Sorry. Actually, BaltSense is a sixth sense. That was actually sort of what I had in mind when I came up with when I was trying to name the project. It may not be the permanent name, but I needed to name it something. Okay, so now what I want to do is let's go and let's see if we get, how lucky will we get that I need to get to Octopart. Which browser? Oh, okay, yeah. Okay, so the light sensor, we're going to use this one. So now let's go back to KiCad. Let's edit this light. We'll use that one. Humidity, let's do temp. Just do this so that we have everything listed in here. Sound, which is really microphone, but that's going to be fun. I'm looking forward to using that because I've never used a PDM type microphone. Like when we use the Grove board, it just has an electric, I forgot how to say it now, but basically just an analog microphone. So we'll have to do a little bit of work with that. But it looks like that Adafruit's got some libraries we might be able to leverage. So that'll be cool. And then we'll find parts for this later. I want to get some of this other digital stuff done first. Okay, so let's start with the RTC because that one's a little bit easier. CR 2016, it is CR 2032. That is the battery that I have. Thank you. I knew as soon as I knew I would, if I saw the, I knew if I saw the name number, I would get the blah, blah, blah. Now, wait a minute. I might have been incorrect earlier. This says there's an SoC 8 version. Really? Is that really the case? Because I would much rather have a smaller chip. There is. Oh, okay. Is that an option? Let's see. Let's go with the first one. Wow, not only is it an option, but it's less expensive. Oh, there's no stock of it. This is an MOQ of 100, so that's kind of bummer. Also, I don't have this one, so gosh, what are we gonna do? Because I would actually like to have the extra space. That's not what I want to do. What's this? Okay. Oh, it's just coming up with it's coming up under the old Dallas name. Have you ever used a processor that uses sharks? I have not, but has anybody in chat used that? That's not something that I'm familiar with. Oh man, this is. See, the thing is, we can get 3 of the parts from Newark and a final part from Arrow. We get 3 of parts from DigiKey and the final one from Arrow. Okay. But nobody has all of them, and that microphone is what's probably really killing me. I wonder if Arrow is even going to let me order only like 10 of them. All right. What I might end up doing though is, because I think Arrow sometimes has free shipping. So I might end up ordering these two from them. Okay, let's look at the, I just realized I'm bouncing back and forth. So I wonder what's the difference between the 16 pin and the 8 pin version of this chip then? Is it just like, so SDL, SC, no connect with connections to ground. I wonder if that's just for stability or what. But yeah, that's just weird. Why would they do this package? Because this is all the active pins are on the top part of this package, and then the rest are just ground. Okay, so sun sensor 2. Yeah, well, that's why we're putting the light sensor on. A sunburned scalp is absolutely miserable. I think only once have I actually had a pretty bad burn, and the thing that sucked about it is it made sleeping so difficult because you know how your nice soft cold pillow normally feels great. It was like stabbing me every time I touched it. So the first couple of nights I had the sunburn, I did not sleep well at all. Okay, I think we are going to switch to the 8-pin version of the 3231 because I definitely want the smaller. And I'm willing to take a little bit of a hit on this one because I might actually order 100 of them because I use these a lot. So I just didn't ever catch that there was an 8-pin version available. Let's actually go check this out. Okay, I just want to make sure they're not discontinued. Yeah, why have a chip double the size if you won't use the lower half? I don't know. I can't think of a good reason. Okay. All right, so cool. That's the first time that the KiCad library actually helped me pick apart. I shouldn't say it that way. I'm sure it's helped me before. Okay, so we'll add one of those. And then let's go back to its data sheet and see, does it have a typical application? Because I think about the only thing we need might be pull-up resistors for SDL and SCA. But we're not going to use them because no, we are going to put pads for pull-up resistors because just in the unlikely event we connect to a processor or something that doesn't have built-in pull-ups, then we'll want to be able to add them. So I may not actually use them, but we'll go ahead and add them in. And so, okay, so let's go ahead and add. Let's go for R small. So we're going to need 1, 2, and it looks like they want us to do pull-ups on SCL, SDA, 32K, interrupt, not reset. Okay. So let's go ahead and then copy this over to here. Oh, you know what I should have done? Let's set the footprint before we copy those. Now, normally I design with 805s, but I think for size reasons, I'm going to stretch myself and go to, nope, we're going to use 805s. I was going to say go down to 0603, but I just realized I've got tons of 805 surface mount parts, and I really don't want to go ordering 0603s if we have enough room for 805s. And I don't want to do 0402s because I have my, using my laser cutter to make a stencil struggles with 0402s. So let's do, Resistor, surface mount. We're going to do 0603, nope, 805. I'm not going to do hand solder because we'll actually use my oven for these. And then the value, I'm just going to say 4.7K, but who knows? Okay. And then we'll have 2 of those and 2 over here. And we'll wire this one, and we'll wire that one, and then we'll wire this one, and we'll wire that one. And then we'll add plus 3.3 volt. I'll do something like this, and then we'll go wire from here to here, wire to there, wire to, oh, come on, go to there, and then we'll go to there. How much will 8-pin versus pin count change the layout of the board? It's purely useless pins you won't need. Yep. Yeah, I mean, they're just ground connections. Maybe it does something to help with the stability of the internal oscillator, but I doubt it. Possible, I don't think it's worth it. I think on a board where I'm pretty sure I'm going to be, I would rather use the 8-pin version and buy some new ones, and then be able to have extra room for the 805 pull-up resistors. That's how I'm going to justify it. All right, so let's call this DS3231 reset. And then we'll call this one SCA. Ah, there's no such thing as SCA. Come on. Supposed to be a professional, man. I swear. It's almost like you're making this up as you go along. All right, let's move G, no re. Let's do G. Nope. Oh man, I was hoping that was going to work. So G. Let's move these up to here. G. Nope. G and G. All right. This is 32 kilohertz. That looks terrible. Let's try and move this over, move this over, move that over, move this over, move that over, and then move this guy over so that we can move this to a reasonable location. And then we're going to call this one DS3231 interrupt. All right, cool. And then we probably should add one of those ground thingies that I always hear so much about. Oh, you know what we never connected was that. All right, let's go ground. Do this, and then a small wire to connect that. Sweet. Except for the battery, we've got one done. DNP and KiCad. I feel like I read something about that. I'll have to think about if I can remember where I read about that. What are we working on today? We are making a wing for a feather. So Adafruit has a series of boards called the Feather. It's a small little form factor. And we're going to put a couple of sensors on this feather that I want to use to create sensor logging nodes for around my house, among other things. So, okay. Totally not my favorite look for this schematic, but we've got it labeled. Oh, we still need the battery, duh. Let's go bat, cell. Is there anything they do specific for coin cells? will do power for battery. Doesn't look like it. But it is single cell, so we'll at least go with that. Put this over here. That's right, I don't have a third mouse button. Oh, you know what else we need? I'll get that in just a second. Let's go copy. Okay, add, and then we'll add battery voltage. And then we'll put that over here. Nope. Put this here, wire that down here, and then hover over that, hit M, and move that so that's a little bit cleaner. The thing we almost forgot, and I can't believe I of all people would forget this, is a capacitor small. Where is just capacitor small? And what we'll do is, okay, I'm gonna put it like here. I'm gonna move this whole thing over. Copy this and copy this. And this is just gonna be a, tip to remember, I think I have 0.805 1 microfarads. That's probably more than enough for a decoupling cap. So let's get that in there. And the value will be 1 UF. And actually, that's going to be a totally rough number. It may actually be a 10 microfarad. It just depends on what I have. So I want to do, oh man, I forgot what we called it. Was it a 2032? Yeah. CR 2032. And we need to find a footprint for that one, but we'll do that in a second. Yeah, I don't know why tab and G are separate shortcuts. Yeah, that's kind of annoying. I'm surprised that that happened. You know, that's not what I would have expected. Okay, all right. So we got that more or less wired up. So let's do this. Let's put our DS3231 RTC. And we'll just kind of put that somewhere around here. And then for the moment, we're just gonna grab this, move this up here. I mean, I might come back and clean this up later, just make it a nicer looking schematic. But for now, I just wanna make sure we get all of the stuff we need into here. Okay, cool. One chip down. Let's do, should we just go from bottom up? Nah, we still gotta find these two holders, but we'll come back and do the coin holder and the SD card slot very last. Let's just go up, keep going up on the list. So now we're on the MP, so this is basically the PDM microphone. Okay, so I wonder if, well, let's first see if there's anything in here for one. Of course not. Get rid of the ordering code. Of course not. So let's go and see if the internets can save us. So we'll just do a search for KiCad and this. Does Snap EDA have it? That would be awesome if they do. I tend to trust their stuff pretty well. Awesome. All right, how about that? Thanks for coming by, Rod. Good luck on your good luck on studying. Wait. What's the difference between this and this? Oh, the symbol and footprint versus just the footprint. Okay. So we're going to download KiCad 4 and later. Sign in. How do I log in? Log in here. Let's do this real quick. Why is that taking so long? There we go. All right. Hey, Dr. J. Today's project is making a sensor board for the Adafruit FeatherWing form factor. All right, so did that download? No. So that's always annoying. I just totally did the wrong one. Download version 4 and later. Okay, you might also be interested in, yeah, we might be, because it turns out this one is discontinued. But I want to use it anyway. So let's delete that. We'll do this one. I'm going to do this. And then I'm going to move the, well, what we can actually do then is, let's do 7-zip extract to here. We're going to rename this because it doesn't need the 1 anymore. And then I'm going to copy that over into my KiCad download folder. Let's go download it libraries. Now the question is, what's going to be the right way? Let me see what they say to do. I just want to see their directions, because the question I'm going to ask is, what's the right way to import into KiCad? How to import into Altium? Oh man, I don't want to watch a video. Who watches videos? Yeah, tools, edit schematic symbols, manage libraries, add. Yeah, I guess we can do it that way. What type of sensor? So sound, light, temperature, and humidity. All right, so now we're going to run KiCad, and we're going to, let's go to, I know I should do, but that's not what I'm going to do. Let's go to the, what am I looking for? This is the symbol editor. Let's load up my library. Where's it at? What? Where's my library? WTF. All right. That's not what I'm thinking of. Don't I just have like a folder called My Libraries? Oh, there it is. And that should be global. All right. I keep forgetting this isn't the computer I normally work from. That's why. All right. And then we want to import, and we're going, oh, why can't Windows remember file open dialogues like Mac OS does? This just drives me crazy. I mean, I don't understand why every file open dialog has to have its own last directory. So download it libraries, this one. Ooh, what's all this about? Let's move that. Unavailable. Move ST micro. What is all this garbage? Now I'm hoping gray means that it's not going to show up. But I guess we'll see here in just a second. So let's do a save. Close this, come back to my schematics, add, and then we're going to do M. What was the part number? MP34. All right, cool. Well, that saved us a little bit of time. Awesome. Can do measurements using sound and light. Also interesting telescope, many more things. Yeah. Stop using Windows. Yes, I know. And if I didn't need a couple of key Windows programs, I would actually be running Linux, but sadly, that just doesn't work out for us. Okay, what's going on here with the pin 5? Looks like a Chinese symbol. Let's do edit, edit in library editor. Let's edit pin. What? Oh, I see what happened. There's multiple ground pins, and they were all on top of each other. Well, that was awkward. Okay. So what I'm going to do then is just move them all down here, because I don't know why they would be on the side like that. And then we could have actually made this whole symbol smaller, but I'm not going to take the time to do that. We'll just do something like that. That looks pretty enough. Save that, close this. There we go. Ta-da! Beautiful. Yeah, pin 5 is multiple ground pins on one another. Yeah, I see that now. Yeah. Okay. So let's take and wire up this and wire that. Add a ground. Oh yeah. Aw, it's not symmetric. Oh well. Let's see now. VDD. You know, a really good question I should ask is, what is the voltage that this thing runs at? Which happens to be a good reason why we got the data sheets. So let's go and get into our datasheet folder. Did I already have that open? I did. Datasheets. Sensor humidity. Open up this one. And let's see now. Single supply voltage. That's good news. Applications. Let's see. The power supply. D out is the PDM data out. LR is channel selection. Interesting. So is this a stereo microphone? That's kind of cool if it is. And then the input clock. So the way that I understand that these work is you give it a clock, and then what comes out is a pulse modulated version of that clock. And on that pulse, and then if you detect the pulse modulation change, that is the analog audio information. So it's purely digital, but you can extract out analog information from it. So supply voltage, typically 1.8, max 3.6. So, I guess we can run it at 3.3. I just wonder if it's really not meant to be run at that high of a voltage. Which I guess we're going to have to, because we're probably going to output directly from the microcontroller. And it looks like that the high level voltage needs to be pretty close to VDD. So we got to run it at 3.3 anyway. Yeah, so we'll do that. And then let's see. So 3.3 volts is going to be easy. Let's see. Do they have a typical application schematic? Because if not, we're going to go find this on the Adafruit board that I found it on and see how they implemented it. Absolute max is 6 volts. Got it. Okay. Soldering information. What's the peak solder? Ooh, good thing I looked. Its peak solder is only 260. That's normal. I was thinking, for some reason I was thinking 350, but that's way too hot for, I don't know why I was thinking of like hand soldering, not reflow soldering. Generally what you want to watch out for on, what I was actually trying to watch out for, sometimes when you look at one of these data sheets, they'll have the peak reflow temperature. And so they're talking about, this is basically during, you preheat, you basically bring everything on the board to a relatively low temperature. And this actually gives time for the flux to activate. And then you ramp up the temperature and you want to hit a peak, but you want to stay at the peak for as little as possible, because this is where the solder will actually reflow, but it's also where you can damage things. So what I was looking at is I wanted to see that the peak is 260, which is pretty typical. Like I said, I just had a little bit of a brain fart. But you need to watch out, because there are parts, like some LEDs will only have like a peak reflow temperature of 220 to 240 degrees. So you would need to be careful when reflowing those. Also, film capacitors are notorious for not being able to hit 250 or 260. We'll have to, so we'll be okay. But what I didn't see is like a typical application, because then that way we know, do they expect some pull-up resistors or anything like that? And so we'll go look at how Adafruit implemented it, and we'll just borrow their design. So we'll add 3.3 volt. We'll do one of these. And then we'll copy this and we'll add a, I'm gonna do it this way. Let's go and grab this, copy paste, decoupling capacitor over here. And then let's see how what we gotta do with these parts. So let's go take a look. What was the Adafruit? Oh, no. I'm gonna have a mirror effect if I do that. I guess not, there's a big delay. So I'm going to come to the Adafruit board. This is where I got this PDM microphone from. And this is actually one where I'm really leaning heavy on them, because I've never used one of these mics before. And so I did find some cheaper ones that looked interesting, but because I've never used one, I decided that it'd be better just to use one that is actually known. So let's go to downloads. And then this is the schematic, and take a look at that. And let's see, accelerometer, barometric pressure, those two we're not doing, temperature, nope. Light, color, PDM microphone. Oh wow, look how, okay, well that's pretty simple. I don't know how to do a partial zoom. So we're gonna have the clock, the PDM, ground the LR signal, okay, we can do that. Ground 5 through 4, okay, or the 5 ground pins, got it, and then 3.3 volts. All right, and then let's just go take a look around here. I want to look and see, where did they connect I don't see where they connected the microphone to. Okay, so PDM clock and data were just pins off the microcontroller. Awesome. So that's going to be pretty easy. Well, how about them apples? That's nice. That's really nice. I don't know what I just pressed. Something's going to load. I don't know what it is. Let's go ahead and edit this real quick. And since for this design, it's going to work out just fine that we are going to we're going to do this, do this one, move this up here. Okay. Save, close that. Let's copy this for left and right. And then this was going to be, oh, nope, don't like that. Every time I hit my mouse button, the line goes up a little bit. PDM clock. I'm actually, because I'm a nerd this way, I'm really looking forward to getting one of these microphones and then hooking up my oscilloscope to it so that we can see what the input and output clock signals look like. I think that'll be really fun. Whoa, oh, that's what I opened. Fusion, go figure. All right. You can reflow at home. I don't remember if I answered that yet. Yeah, I can. I have a toaster oven that I use, and then I have a reflow controller that I built to use the toaster oven. And so I put a thermocouple in, and then the reflow box actually controls the AC. And so I've got a pretty decent reflow profile. It doesn't ramp up fast enough, but for large boards, it doesn't ramp up fast enough. And it's just because I don't think the heating elements I have are all that good. One of my near-term projects, meaning maybe later this year, what I'd really like to do is get a convection toaster oven. So something that has a fan and rotates air, because that will actually help to reflow quite a bit faster and more evenly. And so I'd like to upgrade to something like that. And then that would require, will most likely require doing a little bit more work on the elements and stuff, because I want to be able to control the temperature. And so then in that case, I'll need to control the heating elements, but not the fan. So right now I just crank the oven all the way up and then turn the AC on and off. Makes for a great, it also makes for a really good way to demonstrate EMI, conducted EMI. Okay, cool, microphone is done. Minus, we have to figure out how we're gonna get a package into it, but we'll worry about that here. And well, no, let's worry about that right now. Why are we gonna worry about that later? Duh. How are you getting the 3.3 volts? So since this is a wing that will plug onto the feather shield, we'll get the 3.3 volts directly from the feather that we use, which I really hope they offer a 3.3 volt regulator, because now that I'm looking at this pinout, that might not be the case. Oh yeah, there it is. Yeah, I was pretty sure feathers have like a LDO on them connected to the battery so that they can do, so they can do 3.3 volt. Get a reflow master by Unexpected Maker. Yeah, actually Sion's reflow master is really cool. If I didn't already have my own controller, then I would buy one of his. And in fact, if you want the fun of building one, then I've got all my stuff online, but his is a really nice product. Yeah. So the LR signal lets you decide the clock polarity for communication. That's interesting. I'll have to go back and look into that. Note. Does the LR signal actually do? And what does clock and data look like on a scope? Okay, that's just notes for myself. Yeah, cool. All right, save that. Next up, oh, we got to do the the footprint. How am I going to do that? Ooh, that's the library symbol. Silly. How am I going to? Yeah, think about the right. There's the way I do it and the right way. Might be able to use I squared C. I squared C for what? A welder's blanket for insulation to control the temperature. Wow, that's pretty intense. The actual that would actually help with probably help with the ramp up, because then it's losing less energy. But one of the actual big problems I have with my oven is that the PID, the process integrate decide, I forgot what PID stands for, but the controller that controls how it heats up, it really struggles because there's nothing that is actively cooling the oven down. So when you turn the heat off, you still have this thermal mass that keeps going up, and it gets slower and slower and slower because the only thing you have is basically ambient to bleed off. And so I actually found in some of my testing, if I had a fan blowing onto the glass door, then the pig could actually more accurately control the ramp temperature, because by shutting off, it caused an active change to the state of the oven. Whereas if I just let it passively cool, then it was so slow to react that it made the curve more difficult. But I wasn't super excited about doing that because I was really worried that the temperature differential on the glass would eventually become a problem. So also I just sort of eventually tuned it so that it worked well enough, but how do I add a footprint to the project? I thought this was going to open up like something like the symbol library. I guess I just have to go in here, libraries. I always do that. Add this. This is where I feel like this is one of those things where it's like I always have to say about KiCad that for the most part it's pretty good, but here's an example of where things aren't consistent between different programs, and I never quite feel comfortable with what I'm doing. Is this the right way, or is this just the only way that I know how, right? So if we add that, I want to do PDM mic. Okay. Because now if I go back to this, if I come back into here, is it going to show up on this list? Of course not. So that was not the right way to do it. Derivative. Yeah. Oh, I said process. Proportional integral derivative. That's right. Okay, so why didn't that open up the footprints correctly? Why is that slow? Why? I don't know why it takes so long to load. I2C for the mic. Yeah, so the PDM style microphone doesn't use I2C, and in fact, mics and speakers usually use I2S, which is it's like I2C, but it's specific to audio, specifically because you usually only have data going in one direction for an I2 or an I2S device. But PDM microphones don't work that way. It's pulse density modulation. So the density of the pulses is what gets converted, is you take your analog signal, it gets converted into this density format, and then you calculate from the pulse density what's going on with the analog waveform. And so it's a really efficient, really low power way to get audio data transmitted. And so that's what we're doing with the PDM. That's why I said I think it's gonna be cool to look at it on the scope so we can see what it's doing. Yeah, okay, so that didn't load. Well, I don't know why. What am I? Nope. Oh, I don't want to do that yet. So how do we tell it to use a footprint from another file? Why isn't it? Y4, Y4, Y4. Y4, is it not working? Okay, it's not here either. Okay, new footprint import. Nope, that's not what I wanted. That's not what I wanted. Import footprint from KiCad. Maybe this will do what I want. Man, it's been a long time since I had to do this. Most of the time, the footprints I need and want are already existing. Okay, now where is this going to save to? Can I say new library? KiCad, I'm just going to say my footprints library. Global. Okay. Yeah, sure, save. Name in library. Didn't I just do this? Save. Okay. Now we can come back in here, edit this one, open the footprint, my footprints library, microphone. Okay, so I don't like that. Mind moving chat to the left side. Ooh, yeah, no, sorry. What I can do though is, let's do something like this so that you can at least get a better view of what I'm doing. Oh, come on. Why do I don't want to go banning people. God. What? Okay. That's going to drive me crazy. Let's go in here. I want to become famous. Let's do report. Let's go spam. Okay, we'll call it a bot, whatever. It is spamming. I don't know what else you didn't. Isn't that the first thing I said? And so let's block them, close. But that didn't. Is my mod chat not enabled? What's going on? How you delete? Whatever. Oh, you're driving me crazy. Okay, well, just boy, if you could figure out how to delete it, that would be fantastic. I can't. Not today. Okay, what were we doing? We assigned the footprint to that, so now we can say the microphone is done. Now let's move on to the light sensor, which is going to be this guy. And come over here. We'll put it down in this kind of area. Let's just see if we get lucky. Nope, didn't expect that. And, dang it. Let's go to snap footprint. Yeah, it might actually be the first time we had to delete a message on Twitch. I know how to do it fast on, well, I'm not going to say that because then somebody's going to try. Okay, this was not created. Be cautious when using in your design. We'll be fine. Download symbols and footprints. KiCad 4 and later. You've just downloaded, blah, blah, blah. Oh, yeah, okay. This time I'm not interested in that one because this sensor seemed pretty cool when I looked at it. And there's another project I have in mind that I want to use this one for. So haven't used this one yet either, but I'm looking forward to that because it does gestures as well. And so I've got a project that will require gestures. So I'm excited about that. Let's do import. I just did the wrong thing. I want to come into the library editor and then let's go to click on my libraries, my library, and do import symbol. Oh, you know what we didn't do yet? We need to unzip it. So let's go to my downloads folder and right click. Nope. 7-zip, extract to here. And then let's go, actually, let's put this in my Dropbox folder. That way my other computer will have the, let's do download it, do this. Okay, so then we can come into here and we're looking for the APDS lib. All right, that looks okay. I don't know why people like to do power and ground on the sides. That bothers me. Not so much that it's annoying, it's just weird. LED-A, okay, LDR, anode cathode, yeah, okay, so LED, anode cathode, LDR, interrupt, and then we want clock and data to be on top because there's gonna have, oh, come on. Let's get all of this stuff out of the way. Actually, we are not going to have pull-up resistors on this one because we're just going to have one set of pull-up resistors for the entire board. So we'll clean that up here in a minute. Okay, I like that better. Better. Mucho bettero. I'd love to learn about I2S and PDM. Yeah, actually, that's I think doing I2S. I would too. I know a little bit about I2S because for my scopes at work, we have an I2S decoder. So I've looked at I2S traffic before, but I haven't personally done anything with it. PDM, this is my first time, which is why, again, I said earlier, I found cheaper PDM microphones that would work for what we're doing. But I figured I'll just use the one that Adafruit used on one of their boards because then they've got the libraries to go with it. And then we can learn how it works. And then from there, the next design that I use a microphone, maybe I could try using a new one. You would think ground is on the bottom because the ground is out. That's where the ground is outside. Yeah, good point. You know, that's, I mean, the other thing too is somebody create this, right? Well, I wonder if maybe this is like just something about Snap EDA because Snap EDA is, they basically do, so they have footprints and schematic symbols for various CAD programs. And so it could just be that whatever tool, whatever native format they have, it's just easier to normalize in this way. So we should probably go find out what these are for, or I'm just going to cheat and look and see what Adafruit did. The name of this stream should have been The Bald Engineer Wanted to Be Adafruit this time. I wonder if I should, it would be kind of, no, I don't know if I should say that out loud. I'll think about that later. Where did my schematic go? I closed it at some point, apparently. All right, so let's go AD, what was it called? APD, yep, APDS blah, blah, blah. Let's put that in here. And then let's go take a peek at the Adafruit one. Instead of the correct thing, which is we should go look at the data sheet and make sure we understand what everything in the data sheet says, but that's just not happening today. Nope. Nope. That's a big flat nope. Okay, so this was the light sensor. So we're going to have to redo the, what is going on? I swear, sometimes. So VDD ground, that's easy. LED anode is going to go to here. LED K, I almost feel like we should read about this because I don't know how I feel about what's going on here. Let's do this. Copy image, and I want to be able to do this. The bald engineer got a delivery. Yeah, I don't know. Would a stream where I'm putting together a fire pit and a grill be fun? Because I have a new grill, a fire pit, and chairs. The chairs aren't here yet. I actually thought that's what was coming today. Oh God, does that mean we're going to get another delivery? But anyway, I'm going to have to put that stuff together at some point. Maybe next weekend when I have like tools. Okay, why is this not copy and pasting? Hey, my DEF CON t-shirt shipped. That's cool. That is cool. Let's go. All right, let's go to Photoshop, file, open. All right, the whole reason I did this is just because I want to be able to actually zoom intelligently, because for some reason Firefox only has freaking huge and wee small. Why is VDD and ground together on the chip? Don't know. Okay, so this isn't connected at all how I thought it would be. Okay, so we're gonna make, let's do this. I'm going to lay out my pins the same way they did theirs on the right side, and on the left side, I'm going to do VDD, LEDA, and ground. So let's first do that because I kind of think I understand what they're doing, and I like their layout. I like the wait a minute. What did I just click? Properties, edit, and library editor. So let's go. The anode, I think, goes on this side. The cathode is going to end up over here. Power is so VDD. I think this go in the middle, and then ground. We'll move this one over here. Let's see, and then I understand, well, I don't actually understand why they did it this way, but we're going to copy it so that brain can our function more better. Okay, so LED K, so LED cathode, LDR. I'll put this one up here. And then int, SCL, and SDA, I don't care about. I'm not as worried about what order I get the I2C pins. That's not what I want it to move. I want this. Okay, put this back over here. All right, so we'll do that first. So let's close this and make sure that gets updated over here, and it did. So the easiest thing is these two are going to get connected together, and ground goes to ground. All right, and then LED A and this are connected together with a capacitor. Oh, it's just a decoupling capacitor. Okay. So we're going to do this. Copy this, bring this up here, and then, all right. APDS 9960 light prox sensor. Let's see, Indeed, hello. Didn't you have something to do with the Element 14 community? Yes, I host a show on Element 14 called Workbench Wednesdays. Does this one work? All right, so really, what is going on? Google Translate. Korean. All right. Okay, let's come back to, and then for over here, for those of you on Twitch, so you can see the same thing. Okay. Hello to Korea. How you doing? I've been to South Korea a number of times. In fact, a year ago, 2 years ago, I went for Chicken Festival in Chimay. That was super fun. Tons of fried chicken and tons of beer. That was a good time. It was hot and humid, but it was still a lot of fun. SDA. And then we're going to do SCL. And then I want to do up here, we're going to change this idea. I'm going to just delete this and this. Let's move this over one. And then we're going to delete that, copy this to here. And then move all of this stuff. I don't know. We're just going to move it out of the way. Oh, come on. Don't do this. We're just going to move it over here for the moment. And we will then go let's add a label. And again, these are probably, I'm probably not even going to populate these, but just in case, I think it's good just to have the footprints ready to go because we'll rely on the processor. And if we run out of space, then I'm going to delete those. But we'll have to see. Heard the chicken has a perfect kick to it at the feast table. Not sure what that means, but in terms of flavor, yeah. I mean, it was I probably tried 24 different styles and flavors and I was gonna say sauce, but there was very few that had sauce. They were all really good. It was just, I would 5 out of 5 would do again, absolutely. Okay, so we need to do an we'll do this, and we'll do ADPS int. Move that over one more time. Move these over. Yeah, that's what I thought. Move these over. And And then just kind of make that look all nice and clean. Okay, beautiful. Oh, so exciting. Okay, so, I just realized what we're doing with this schematic is the programming equivalent of using Stack Exchange to write a program, where we're just copying and pasting a bunch of elements from somebody else's stuff into our own. So yeah, so that's what we're doing. That's the third or fourth title for today's stream. Okay, now we're going to take this sensor, and so what is this? This is the SHT. I'm trying really hard not to mess up that name. I've heard you had to use different resistors for different I2C data rates. That's a very big, it depends. For faster I2C, you want relatively strong pull-ups, meaning very small values, so that you have less of an RC curve for fast transitions. But keep in mind, fast I2C is really only 400 kilohertz. So you really want relatively small resistors, simply because you want a nice strong pull signal. What you don't want to use sometimes are the built-in pull-up resistors of a chip, which is why I want to put the LED pad, or I want to put resistor pads into the design, because sometimes the internal pull-up resistor might be on the order of 30 to 50K, and that's considered a weak pull-up because there's very little current, so it pulls the voltage up very weakly, and that might not be strong enough depending on how much trace length you have between your chips or your I2C devices. So that's why, again, I'm putting the pads on the board, but when I actually manufacture these, or when I build them, because I build everything by hand, I probably won't even bother putting those parts on the board, because I probably don't need them. It's just there as an insurance policy. Okay, so I think I tried this, didn't work. Let's check again. SHT30, SHT. Oh, this is, ooh. Oh, could we be so lucky that at least we have this going for us? Except that's an SHT1 and I have an SHT3. So what do? We go look at the datasheet first and see what it looks like. It should be this one. SHT3X. We could actually just look at, does this have, no, that, okay, I thought that had the pinout in it, but it does not appear to be the case. Here we go. There we go. That's what I want. So SDA, SCL, an address pin, the alert condition. Okay. I didn't know there was an alarm signal. That's cool. Supply, reset, okay. No connect and ground. So we're looking, so what I see here is 1, 2, 3, 4, 5, 6, 7, 8 pins. And if we look over here, there's only 1, 2, 3, 4. So that symbol's not going to work for us. Okay. So what we're going to do now is kind of rinse and repeat. I'm going to go check Snap EDA, see if it's there, copy that in, and then we're going to check out the other pins. I'm going to take a 3 to 4 minute break to use the restroom and grab some more tea, and then we'll knock out this last sensor. And then at that point, what we'll do is we'll look for the coin cell and the micro SD slots, micro SD sockets. If you guys have suggestions for a part to use for the micro SD card socket, so basically just the socket, as well as the coin cell holder, which is going to be a 2032, then I would be very much open to looking those up, and it saved me a little bit of time to have to go and search for things. And frankly, even if you offer a suggestion that I can't use or don't want to use for some reason, it still will help, because then we can at least talk about why I might pick something else. Or if I do use it, I can talk about why I like it. So let me go take a really short break, and then I'll be right back. Again, apologize, no trivia, no games. All I got is my standby screen, but I'll be back in just a second. And of course, as always, feel free to talk amongst yourselves in the chat. There's a KiCad library for the coin cells. Okay, good. Yeah, that's actually good because now I think about it, I already have. We just have to find the right footprint because I've got they're the metal clips. So you basically just put the put 3 solder pads down and then reflow that. And so I've already got a bunch of those. So that's what we're going to use. Yeah, this time I didn't, so thanks for the reminder, Dr. J. I didn't actually forget the microphone this time. I was eating. I just didn't want to turn it back on until I was done eating, but I figured I'd let you see my beautiful face sooner than just the getting started screen. And I'm joking, by the way. I don't actually think that highly of myself. Okay, so did anyone come up with a micro SD card slot or socket? Because that's one that I don't have at all. And so we'll have to find an appropriate part and to do that, which I don't think is going to be too difficult. I just don't have one. Okay, so let's look for what we're doing now. We're doing the SHT30. So let's go back to our friends at Snap EDA and look for SHT30. SHT30 DIS. DFN8, I believe, is what we have. We'll go double check the data sheet to make sure that that is the case. So, but that does seem like what we're looking for. Let's see. This ought to have like a table with all the various with all the variations. Okay. That's not quite what I was looking for, but maybe I'm looking now for package style. It is a DFN package. So we're looking for something that looks roughly like that. And about the only thing missing, I think all they're doing on this is supposed to be the pin 1 indicator. So I think we'll be okay. So let's go with that. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9 pins on here. But we only have 8 pins. Oh, maybe 9 is the ground. So let's go back to the pinout diagram. Okay, this has 8 pins. So why does my schematic symbol have more than 8? Unless one of those is one of these the ground pad. I bet EXP is probably. I bet this is supposed to be the. Oh yeah, the ground pad. Okay. Oh, that's pretty cool. Check this out. As I keep forgetting about the chat. As you hover over the pads, it lights up on the schematic symbol. I didn't know they did that. Yeah, I know Adafruit probably has a micro SD socket, but what we're going to do is it'll actually be a good exercise. We'll use Octopart as a way to find it, because I know everybody likes to just go to a certain distributor and search for parts, and hey, if that works for you, that's great. But I tend to try to start with something like Octopart, because since it's searching across distributors, it just kind of looks at data in a different way. And so anyway, we'll get to that. So for now, what we need to do is go into our library editor and do a, let's go import. And I also realize I'm not gonna do this now, but I shouldn't actually be importing these into the my library, because my library was originally intended to be parts that I make or symbols that I make, and not the ones I download. What I really should have done is created a library of just downloaded parts, because that makes more sense. And then that way I can differentiate the ones that I got from someone else versus the ones that I made. But that's okay. Not like I said, it's not something I'm not gonna get too wound up about it today. Okay. Man, it is raining. You guys hear the rain? Let's move this. Kind of glad that the stuff got delivered when it did. All right, thanks for the coin cell holder. That's interesting, RJ. I would have thought they would handle global pricing correctly, and I understand. It's Canada is not exactly really far from North America, or from America. I guess Canada is really not far from North America, but let's see. Okay, we're just gonna go with whatever this has. Save that. Close this. Oh, why is Fusion still open? I must have minimized it earlier. Okay, so now we can go in here. Let's look for an SHT. Add that. So this is going to be easy. We're going to take, and one of the things I should probably do on this schematic is I should probably label what all the I2C device ID addresses are, because with the exception of the microphone, I think everything is I2C. So I think it would just be good to make sure that those are labeled and taken care of. I'm going to guess this is 3.3 volts. I forgot to look. Let's get the ground over here, and then let's go ahead and get our decoupling capacitor. Excuse me. I don't have a way to copy and paste, which I just now realized is going to be a pain. So what do you got? 3M 290805 WBMG. Thank you. Okay, we'll look that up later. Thanks for the follow. I'll just call you Mike C. We are designing a FeatherWing. So feather boards are a series of boards from Adafruit, which have a standard form factor and pinout. And so we're making a wing, or like the Arduino term would be shield, that will plug on top of it, on top of a feather, and it will provide a temperature, humidity, proximity, or light and sound sensors so that we can do some data logging and such. So, because I looked around and I couldn't find quite what I was looking for in any boards that already exist, so we decided to go this route. Okay, now let's go back to our schematic here. So pull-ups. Everyone is showing a 100 nanofarad decoupling cap, and while I always recommend doing what the datasheet says, my very good friend, Dr. Eric Bogatin, had a lengthy discussion with me about why you can basically use a 10 microfarad ceramic or a 100 nanofarad ceramic and still get about the same kind of performance from either. And I totally agree with him. And long story short is you have to remember, with a multi-layer ceramic, you have multiple layers of capacitors. And so you actually effectively have multiple capacitors in parallel with each other. And so with the ESR being so low, the overall impedance is so low that it's actually no different than putting a 100 nanofarad and a 10 microfarad in parallel with each other. Now, I want to be careful, because that is very different from putting in a, say, 10 microfarad electrolytic instead of a ceramic, because electrolytics have very high ESR, have a ton of inductance, and so their impedance profile is very, very different from a ceramic. Physically, they're also built different. So long story short, if you've noticed, every single data sheet we looked at usually has a 100 nanofarad capacitor for the decoupling capacitor. I'm going to cheat and use a 1 microfarad so that we get a little bit of decoupling and a little bit of filtering. Two different applications for the capacitor, even though we call it the same thing. Anyway, reset alert. Okay, so those are all taken care of. I don't know what R is. What's R? No electrical function, connected to ground. Well, fair enough. Alert is alarm condition must be left floating if unused. Okay, we may end up leaving it floating. Reset pin active low input. It is not used. It can be floating or connected to VDD with a series resistor of, well, that's not a series resistor, that's a pull-up resistor. Okay. And you guys already know where I'm going with this. Let's go see what our friends at Adafruit did for their implementation. I totally blanked out. What are we doing? Oh, the humidity sensor. So they left alert floating, and alert is floating. They actually pulled up reset. But see, they pulled it up without a series resistor. Game Tech, yeah, I smelled a custom PCB in the works. Yeah. You actually, I need to give you credit, because when you said that the other night, my first reaction was, no, I'm not going to build something for this. And then right after the stream, I thought I found, this Adafruit board, which we're basing this all off of, is really close to what I wanted, but just not exact. And so then I'm like, oh man, Game Tech's going to be like, yeah, I told you so. I knew it. So you did. Okay, we're not doing the 280. Anyway, so SCL VDD, so alert. I'm actually going to deviate. I'm going to do what the datasheet says, which is tie it high with the resistor. Excuse me, sorry. And then alert will leave floating. I guess we're not using that. No, I'm going to actually tie alert to something. But what we'll do is we'll put it through a solder jumper. So reset, we're going to grab one of our pull-up resistors, and we'll pull that up to 3.3 volts. Address, so let's double check what the function of address is. So address pin, input to either high or low, do not leave floating. Okay, and so that's probably setting the I2C address. And so what I'm going to do at the moment is rearrange this symbol so that we can make it ground and make it clean. So let's move address down here. And then I'm going to add a note. We need to double check that the I2C address is okay. Because if you remember, well, the whole idea behind I2C is each device has to have its own address. And so usually what happens with stuff like this is the last bit of the address is something that you can tie high or low, so you can change the address to be, say 30 in hex or 31 in hex. And so we do need to double check what base address this is using, and that it's not interfering with anything else. So I think we will do the thing where I said we'll go through and look for it. Well, let's look for it right now. I've already got the data sheet open. I'm just going to look for address. Do you need to fill in a form? No. Why would I fill in a form? So that way you guys can see what I'm looking at. Let's see, table 8 for the respective addresses. Okay, so let's go look for table 8. Yeah, oh, yep, it is there. Good job. So it's going to be address 44. So see, this is what I was talking about. If you tie that pin low, it gets address 44, and if you tie it high, it gets address 45, because the least significant bit of the address is what you're setting. And then I'll just leave it there. Let's see, can you please explain the differences between different capacitor coefficients? No. Alert should be tied to a transistor if you plan on driving an external device. So that's a good idea, Michael. What I'm going to do is I'm just going to tie it to an I/O pin and basically just have it available, because I do think I could see a potential use where if it detects I think the way this works is the sensor, if it detects, oh, yeah, we're going to do that, because we're going to do that, but the reality is I'm only going to be checking the humidity and temperature when the board is powered up, when the microcontroller is running. So I just thought of something. The feather doesn't control the 3.3 volt. So even if we put the microcontroller to sleep, all of the sensors are still going to be running. And so what we probably want to do is have a power control for the sensors so that when the micro turns on, it can then turn the sensors on, get the readings, and then shut them back off. Thanks for the follow, OKI Coswig. So Lorenzo, I meant to make a joke about not explaining the capacitor coefficients. The thing I don't want to, because I'll talk way too long about capacitors. Let's check something. I think I have an article that I can just point you to. I just don't remember where it's at, because I know it's something that I've explained multiple times before. Nope. Nope. Okay. Long story short, ceramic capacitors come with 3-letter designations. So C0G, X7R, X5R, Y5V, and those define what happens to the capacitor with temperature. And so C0G, which was also known as NP0 or NPO, basically says that it changes plus or minus 30 ppm per degree C. And so the C, so one of the letters is from, is like negative 40 or 50 degrees C up to 200 degrees C. It changes like by 2 to 3%. So it's very, very, very stable across temperature. X7R, the X is negative 55, the 7 is plus 125 degrees C, and then the R is plus or minus 15%. So from negative 55 to 125, the capacitance can vary by up to 15% depending on the temperature. And the way that the profile gets worked out is it'll actually peak up at 25 degrees C and then come back down. So as you get away from room temperature, you lose capacitance. X5R has the same shape. The X is negative 55 degrees C, but the R is now 85 degrees C. And so it's in its rated temperature range, it'll still lose 15%. Now, you can actually use X5Rs up to 125, but then their capacitance drops off even more. It could be up to like 30% loss as you get higher. So for anything where the capacitance value is critical, you want to try to use either C0G or X7R. There's a couple of others that are like X8L or X8S or X7S. And basically what all they're doing is the first 2 letters is the temperature range and the 3rd letter is how far it varies. So I'll leave it at that. The last thing I'll say is the worse the temperature coefficient is, the worse the voltage coefficient is. So remember, ceramic capacitors, as you apply a voltage, their effective capacitance goes down. So while you can buy a 1206 surface mount package rated for 6.3 volts with 220 microfarads, if you apply 5 volts to it, it becomes a 90 microfarad capacitor. And so X7R or X5R has a worse voltage coefficient than X7R, and then C0G has no voltage coefficient. But the problem with C0G is they don't have as much capacitance. And so in a 1206, you can only get maybe 200 nanofarads of capacitance out of a C0G. So that's the briefest I can explain capacitor coefficients for ceramics. Okay. So we're going to have alert come out to about here, and then we're going to add a solder jumper, which will be open. And we'll do that. And then we're going to go another line out here because this is going to be SHT30 alert. . 30 alert. 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 30 Oh, almost got it. One day I'm going to guess those just perfect. And then the solder jumper, we're just going to not even have that be there. That'll be good enough. And then this way we can literally leave it floating, or we can go and attach it to a pin if we want to. But what I'm realizing is that may not matter, because I think we're actually going to change the power so that we power everything off the 5 volt. No, that won't work. No, shoot. I gotta think about how we're gonna do this. Turn on, read, and off. You might have an issue with setting time after power on. Yeah. Michael, you're totally. I was thinking about that as I was saying that out loud. Is what I'm really tempted to do is spin this board as is, but put a 2-pin header so that we can manually disconnect or connect the 3.3 volts, so that we can measure how much current the board draws, and then maybe build up a breadboard circuit to power the sensors separately. And then that way we can get an idea, is it even worth bothering with turning the sensors off, because their idle time might actually be low enough it doesn't matter. Just a note, if you're using a CR20, the 3-point will not come from the Feather. The 2030, the battery is only for the real-time clock. Its only purpose is to back up the clock. So we're not going to use it for the rest of the board. SHTC1 uses lower voltage than the 30. We're using the SHT30 because that's what our reference design is using. And so I just want to go for what already I want to go for what there's already, I want to go for what's going to be the easiest thing to design. So with most of these, we could have probably picked a more appropriate sensor, but I'm making the trade-off of there's less things that I have to figure out if I can just leverage what Adafruit has already figured out for us. And then since So SHT30 temperature. Now, the flip side to everything I just said, because what I'm thinking about on this alert thing is, so if right now we leave the sensor is always on, then I think the way that this works is we can set a threshold where the alert signal will generate, it'll generate a signal, which we could then use to wake up the processor and take action sooner than later. The thing is, if I was planning, maybe once a minute, I guess we could actually, if the sensors stay on, we could turn the micro on. Well, I don't know. Now I got to think about how often we're going to turn it on. But we'll worry about that later. Okay, so we got that now. Man, this power thing is bothering me. Okay, so next up, let's go look for a footprint for the coin cell. And let's see if we can get lucky and just find one in KiCad already, since it's a generic. I mean, those clips are pretty generic. So battery holder 2032, that is not what I have. Oh, that's vertical. I mean, this is more, yeah, these are all vertical. That's not what I want. That is not, no, that's not what I have either. So this is actually what I have. I have something that looks like this, where it's this metal clip, and then the sides solder down, and then the bottom, and I think that's the positive, and then the bottom side is just a pad for the negative. But I don't see one for the 2032. Yeah, that's not it. That looks really close, but it's not, I don't trust that's the right one. So if you consider the file format that's going to be saved to, so for the SD card, we're just going to do a CSV file, which is sort of the code we wrote the other day. And then for the network connected ones, I haven't thought that through yet. I'm just assuming it's going to be Wi-Fi and MQTT, but that could change. But for the SD cards, yeah, they're just going to save a CSV file. And then once every couple of days, I'll swap the cards out and oh man, that's not what I want to open. I was trying to open up Firefox. I don't know why I went to Discord. So let's do a CR 2032. See, this is what I have. That symbol doesn't look like what I want. In fact, that looks like a through hole symbol, and I know what I have is not a through hole. But it looks like it's called a retainer, which I wasn't saying before. So maybe we'll search for that. Wait a minute. Wait a minute, wait a minute, wait a minute. Did I just look for the wrong size? Is 2032, is that the popular one, or is that, no, that's 3032. Oh no, now I don't remember. Let's see. Let's go to Dropbox. I think archive projects. Nope. Let's look for, I'm looking for, it's a project called Accurate Shield. What else do I have that I've used that? There it is. All right, so $2032 is the size of a quarter, 2025 is a button size. So the 2032, I think you're right, is the popular one. I think it was 2025 is actually what I've used. Because it's smaller than the popular one. Let's go info. Okay, I just called it 12 millimeter. That's helpful. But yeah, this is the part that I have. And this says it's a 12 millimeter battery. Okay. How does 2025 and 12 millimeter relate to each other? That's something I don't know. But it does make me think this is actually the correct Okay, now this makes me think I have a totally different battery than what I'm even thinking of. So what's the... I guess in a couple of days I could actually go look at it and find out. I wonder... where I want... Okay, so it's not a 2025 either. I have the numbers backwards. I thought the 32 was the diameter, but that's the height. So what I actually have is a CR12 something. Yeah, okay. Yep. What I have is a battery CR12. Is it 1225? That's what I'm thinking of. And then let me double check. I used to have because I based it off the Chronodot, just realized that we could look at that one. So he used a 3012. I wonder if it was supposed to be 1230. Yeah, okay. So that's what's going on. Yep. Okay. That's weird. That is so weird how I totally remembered it different. So yeah, so this was actually the right part then, because this is the 12 millimeter. 2016. Ooh, really? Well, I know, okay. So that's good to know, Andy. But I know that it's the 12 millimeter part because that's what I used in the old. So I've used this in 3 designs. And so one of them was a shield for the 3231. And so I knew, that's how I know that I have this holder somewhere. So if we put the 12 millimeter holder footprints down, then we'll be in good shape. So that's what I needed. I thought when you said 3032, I for some reason thought that the 32 was the diameter, but that's the height, which now I realize how silly that is, but okay. So we'll save that. And then we're just gonna save this to 12 millimeter so that we don't have to worry about getting the right one. Yeah, 2032 is the popular one, but that's not the one I'm using. I'm using the smaller one. Okay, so now we need the micro SD card slot. So the part numbers you guys were giving me earlier, is that what these were? I thought there was a second one that I didn't write down, but yeah, was this a it's not what I want. That's not what I want. This is what I want. And then let's go, we'll just take this one, go to Octopart. Ooh, that looks expensive. $3. Oh no. No, no, no. Although, yeah, shoot. Okay. And that's pretty well in stock. Micro SD card. Oh, I see what you guys meant. Yeah, Adafruit has an actual, they're selling just the actual part, and it's only $2. Okay, how does that work out? Because it's not like they make this. All right. So what is the phrase that's used? Okay, let's do this. SD card socket. So Adafruit Amphenol at $1.30. Only available at Mauser. Molex has got one in the $2 range, but it looks like limited stock availability. Amphenol, $2.30, but it's more widely available. Okay, so I like that. A little more expensive, but it looks like it'll be easier to get a hold of. Molex part, this Amphenol part, not really available. This Amphenol part is really cheap, and it looks widely available. Mauser Newark DigiKey, so that will save that one. Right angle, uh-oh. Is that what we want, is right angle? Look at the data sheet, double check that. Hey Joshua, thanks for the follow. What size are you using for the coin cell? It is a 12mm diameter part. I don't know what the height is, but for the purposes of the PCB layout, that won't matter. But I will have to, what I do know is I've got the batteries and I've got the connector housings already. So I know that the height is compatible. I had it in my mind that it was I had the part number in my mind incorrect. So, and I'd have to go search through like old distributor part orders to find what part numbers I had and everything. But I think we've been able to reason it out pretty well. Okay, so I think they just mean right angle because of how it connects to the PCB. To me, right angle would say it would come on like this, but I guess they're saying it's right angle because the pins come out and go down. I guess. I don't know why this had right angle in the title, because that's definitely, that's what we're looking for. And it is only like $1.30. So let's add to BOM, sensor log. And now we're going to go over to Snap EDA. You have a rechargeable CR type? Man, I wish I did. So I have this binary clock that I built. It's like this big and it's got binaries. Well, it's actually a BCD clock. And that was one of the other designs I've used this battery on, and the battery died. What I didn't expect is at some point I thought it was a good idea, made it out of bamboo. At one point I thought it was a good idea to glue the entire thing together. So I have no way of getting into it to change the battery now, which is super frustrating because I can't set the time and then move it somewhere else. Because as soon as I unplug it, it's dead. It's dead, Jim. All right, beautiful. This is exactly what we want. Okay, let's download that for KiCad. That is a what? It's a what? That is not at all what I want. Why would you offer me that? It's the way it's hardwired to be mounted left hand or right hand on the PCB. Okay, well, we're gonna go with it, and oh, I think I understand. So which way, so when you put it on the board, which way is the card meant to egress, maybe? Well, we'll go with it. If it doesn't look like it'll work, then we will back up and try to figure out what we're going to do. But for now, I think we're in good shape. So let's go and, what? Okay, extract, 7-zip, extract to here. I didn't even look to see if there was one of these in KiCad already. I just jumped right to the conclusion that it wouldn't be available. We should probably double check that just to see. I mean, I know there's probably a micro SD card in KiCad, but for something like this, I really want the landing pattern for the one that we're using. Download libraries, we'll put it in here. It's the 1000 blah, 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 blah. But let's double check, because if there's a match, then I'm just going to trust it because I like to gamble that way. I have never been bitten by using a built-in library. Never before have I had a problem, ever. Except almost every time I've done it. Let's just do it quick. Nope. Nope, okay. That's cool. I did not expect to have that exact one, and so not a problem. So let's go into my libraries. And then we'll do import symbol. And we're going to go download, and then we're going to go to this one. Okay. That is kind of a mess. Voltage ground. Really don't like this, but I don't feel like cleaning this up at the moment. What is CD switch 1 and 2? Is that, I don't know what that's for. Okay. Oh, shoot. Look at the time. Okay. Yeah, like I said, I've kind of assumed that there would be a generic, but we're not going to use it. What was the, yeah, 11400. Yeah, Big Clive takes things apart, but he rarely puts them back together. Yeah, I don't want him to use his calibrated screwdriver. Is that what he calls his hammer? What kind of projects do you work on as your job? So I've always been in sales and marketing, so I'm a product manager for Rotor & Schwartz, and I manage our oscilloscope products in North America. Before that, I ran technical marketing at Kemet, a capacitor company. Before that, I worked at Agilent I was a FAE and an account manager for oscilloscopes and logic analyzers most of the time. And I also worked at LaCroix for a short period as an account manager. And then I have had a bunch of contracts and smaller jobs in between. But almost always, except for when I did an internship at Dell, my professional jobs have always been sales or marketing. All of my engineering work has been on the side. They did the shield stuff. Darn it. Now, my primary focus has been, most of the time, has been digital or high-speed digital. So like I did a lot with PCI Express Generation 1 when it first came out. And then, and now I still deal with a lot with high-speed digital, but I also do a lot of I'm starting to do a lot of RF stuff. Even though I'm a time domain person, being at an RF company kind of causes you to pick up some RF things. So I've been doing that, or trying to get a better understanding of that. Like, for example, I've been spending a lot of time on how to use high bandwidth scopes to measure automotive radar. So an automotive radar signal is like 76 gigahertz, and spectrum analyzers to do measurements on 76 gigahertz are like $500,000. And so we looked at how can we use a scope and do it for about $100,000, which has some trade-offs, but it enables the measurement and it can be a little bit cheaper, as well as it's one of the few areas where you can get phase coherent measurements, which you can't really do with independent spectrum analyzers. Are you satisfied with KiCad? Used Eagle a while back, not too fond of Autodesk, just wondering if it's worth learning. I think absolutely. I switched to KiCad full-time 5 or 6 years ago, and the only time I use Eagle now is like what we looked at, where I had to go and look up one of my old Eagle designs. I looked at Eagle 9, and I think Autodesk is doing some nice things with Eagle, but there's very few things that Eagle does that I wish KiCad did. And I mean, the evolution of KiCad is significantly more than the evolution of Eagle. Like if you look at KiCad 4 to KiCad 5, 5 was just released a year ago. There was a step function in usability and feature enhancements. And what I'm hearing, I haven't looked at it myself, but from KiCad 5 to KiCad 6, there's another step function in functionality that's happening. If I look at Eagle 6, 7, 8, or 9, it doesn't seem to matter which one you use. When Autodesk took it over, they cleaned up the UI and gave it some new icons, and they've added some interesting new features, but it's not like it's leaps and bounds night and day. I mean, I originally had 9 installed, and then I uninstalled it and reinstalled 6 just to see if I would even notice a difference, and I really didn't. So yeah, I think what I generally recommend to people, if you only plan to make 1 or 2 boards, then Eagle might actually be the better way to go, because you do have to get over the user interface usability, but it's extremely consistent. And so you're only learning how to do things once. Whereas with KiCad, everything is so separate, you sort of have to learn how the schematic editor works versus the printed circuit board editor working. And for a single board, it may not be worth going through all those push-ups. But if you're going to make boards on even an occasional basis, then I say invest your time into KiCad. Yeah. So I think, yeah. Now the primary reason that I'll save this for another time. Let's get this done. I don't want to get, I have a rant that I want to avoid. So, oh no, did I not save that right? I think I did not save it because I was distracted. Yep, that was stupid. Where is refresh? All right, let's start this over. I was not at all paying attention to what I did. There we go. So, but, oh my God, what? Where did all my symbols go? What did I do? What in the world did I press? Because I don't understand what just happened. See, I was just about to say something negative and look what happens. All right, now we're back in business. Okay. So what we got to figure out at this point is how do we how do we hook up all these things? So supply voltage is going to be pretty easy. Ground. I don't know if the SD card shield, yeah, that can be connected to ground. I was thinking of the USB socket that you don't actually want to connect that shield to ground. So clock, that should be the SPI clock, right? And then SD command. And then they've got 4 bits for data, but does SPI actually use that? Let's save this. Have I ever worked with Altium? Nope. I rephrase. I did many years ago. One of my jobs, I did have access to Altium, and I used it a little bit there. But I've had, in the last couple of years, I've had 2 extremely negative experiences with Altium salespeople, and so I'm not super keen on giving it a shot. So look at the grounding on the other IC. Not sure what you mean, Dr. What was it? Or Lorenzo? Oh, I see what you mean now. Thanks. There we go. I must have deleted it when I was getting a little delete happy. Okay. I feel like we need to do something with the data lines. I don't know what CD switch is. Let's go, because these aren't micro SD. So Adafruit micro SD card breakout. So CSDIDO clock. Yeah, those all sound like what I was expecting to see, which this connector does not have defined. So let's go see what their schematic looks like. Yeah, see, they have a totally different, that's troublesome. So data out, data in, clock, chip select. This one doesn't have a chip select. So let's see, 1, 2, no. So 1, 2, 3, 4. So 1, 2, 3, 4. 5 is clock, okay. 6 is ground, okay. Interesting. So I think I want to follow what they did here. So this looks like it's going to be SDD out. And then pin 3 is data in. Pin 4 is VDD. Pin 5 is clock. 6 is ground. 7 is out. That's what I did. And then 1 and 8 are nothing. Pin 2 is chip select. And then card detect CD, okay. Is that pin 9 on hers? Don't have pin numbers there, but I'm guessing that's what that actually means. Okay. I'm not 100% sure why the labels are different, other than this must be using SDIO. So there's SDIO and then there's like SPI. And so to communicate with the microcontroller, we'll use SPI because it's easier and there's already libraries for it. But there is also SDIO, which might actually be this pinout. That's what this might be labeled for, is SDIO, which is not what we're going to use. Yeah, there's 4 lines for quad SPI. That's why I'm thinking this is an SPIO, because I think that's where QPSI gets used, which we're not going to do in this design. What I'm wondering about on this switch though is this supposed to be like, should I connect like one side to ground and one side to a pin with a pull-up, and then this switch gets closed and that's how we detect when a card is inserted? Because I feel like that's what that should be done. Okay. Oh, okay. So let's do this. That's not what I wanted. I needed a text box. I'm gonna just put a note before, when we come back to work on this the next time we work on this, that's the first thing we'll check is, I want to double check what I'm doing with this, because I'm not convinced that I have this hooked up correctly. And so I want to make sure we do that. So at this point, I'm starting to run out of time. And so, although since my delivery came early, maybe I'm not running out of time. Anyway, but I am running out of energy. So what we got is we got an RTC, we got the SD card, a light and proximity sensor. The temperature and humidity sensor is wired up. The microphone is wired up. Let's delete this. We'll leave this over here for the moment. The other question that I want to put in here, just to ponder, is header pin for 3.3 volt node, so we can test current usage, because I need to figure that out. So we'll try that out. But I think overall we're actually in pretty good shape then. I think we'll be, so the other obvious to-do thing that we'll have to do is now figure out the we need to figure out how we're going to wire them up to the feather shield headers. And what I'm thinking about, the note I put in there is I want to look at 2 different feathers and just make sure that they'll work together. So maybe we'll pick like the M0, the basic M0, which is just the M0, the 32-bit AT-Mega processor, and then we'll look at, say, the ESP32 feather as sort of the 2 extremes. You know, one that has that can only be used for logging, and then another one that can that has Wi-Fi and Bluetooth. Yeah, actually needing the datasheet on the micro SD slot, the challenge there is that the Amphenol datasheet, I mean, Amphenol is not really an electrical company. Even though they make connectors, so it's all mechanical data. What I need to go look at is the specs for SDIO and QPSI and see how those match up. But that's why I'm not too worried about right now, and it's something I can maybe do like later tonight and then finish up the schematic. So I'm just going to start wrapping up at this point. I think I'm planning to do a stream on Wednesday, and I think what we'll do is we'll actually pick up with this, unless something comes up, we'll pick up with this design, and basically the next step will be, let's make the PCB layout. And then that way we can get that shipped off and working. And then by the time these boards come back, we'll probably have most of the lab set up, so we'll be able to actually build these and do some testing. But yeah, this will work out, I think. So what we'll do is Wednesday, we'll likely work on this some more, and then that leaves Friday open to maybe go back to doing something more hardware related on Friday. So, all right. Thank you again to everybody in the chat that participated. Just as a reminder, if you'd like to keep the conversation going, and if you'd like a link to the GitHub when I publish this, which I'll probably do later today after I'm going to go take a little break and maybe do some exercise, and then after that I'll upload this to GitHub. But if you want to keep the conversation going, then we do have a Discord, and that's where I will post the link for. That's where I'll post a link to this project, which also means you could also, if you want to go and grab the files and help make some edits or cleanups, I would be totally cool with a pull request. I don't have an Element 14 video coming out this week. It's actually going to be 2 weeks from now, but yeah, so I don't think there's anything going on there. So for now, definitely, yeah, if you want to keep the Discord going, let me know. Now, for all you friends over on Twitch, by the way, if you are following on the YouTubes, I'm getting very close to switching to only streaming live to Twitch. And then what you'll see on YouTube is an edited version of the live streams. Basically, before I moved, I tested being able to record the cameras so that I can make a cleaner edit. And after I get that set back up, then I'm going to start doing that. So if you go over to twitch.tv/baldengineer, you'll be able to keep following me there. That's also a really good place to go for the archives, because I do create highlights of all of the live streams there. You'll notice on YouTube I don't post the archives anymore. So, all right, let's see if there's anyone doing anything STEM related, and then we can go and bother them. Doesn't look like it, so I'm not going to do a raid. Oh, wait, what's Handmade Hero doing? Handmade Hero. See if they're programming or playing games. Here. Oh, come on. Yeah, okay. Okay, I can't tell what they're doing. Okay, I'm not gonna do a raid. Okay, cool. Thanks everybody. We'll catch you later.